Good morning, friends. Welcome to Water Resources Engineering class. We are dealing with the hydrographs. So, in that hydrographs, we have completed the direct runoff hydrograph. We have completed how to extract unit hydrograph from a direct runoff hydrograph. That also we have completed. Then afterwards, to derivation of unit hydrographs of any duration from a given duration, that also we have completed. But in this particular class, we work on how to get the unit hydrograph from a complex storm. How to get the unit hydrograph from a complex storm. What do you mean by that complex storm? That complex storm you can see here also. Complex storm indicates a number of the rainfall pulses. The number of rainfall events occurring one after the other with different intensities. That's what we will deal with. The complex storm, characteristics of complex storm, derivation of UH from a complex storm. What is a complex storm? A complex storm is one in which there are several rainfall pulses. That means the rainfall events have occurred, several rainfall events have occurred, each is having constant duration. What is the meaning of that? 1 hour the rainfall has occurred. So that is one pulse. With an intensity of, for example, 2 centimeter per hour. Then afterwards, there is a gap, a small gap. Then again, another event has a rainfall event has occurred, which a rainfall intensity of 6 centimeters. Then a gap. Then again, one more has occurred. Gap in the sense that not much. The rainfall is increasing, decreasing, increasing, decreasing. That's what I am telling. It's a continuous rainfall event. That's what total is called as a complex storm. So each is having a constant. A complex storm refers to a rainfall event characterized by multiple distinct bursts of rainfall rather than a single continuous uniform downpour. It's not a single continuous uniform downpour of equal intensity. It is actually, it's a multiple distinct bursts. That means one is increasing, then a little bit less, again increasing, again a little bit less, again. It is different multiples actually. Each pulse lasts for a defined time interval, which we call it as a constant duration. But the intensity of rainfall in each pulse can vary. That means whatever the first thing may not be, the intensity need not be the same with the second one and all. Suppose if such type of case, that is what we call it as a complex storm. It is not one unit, one hydrograph. It is multiple basically. So if that is the case, how you are going to solve such a problem actually, right? But when we will go for such type of things, because our ultimate objective is deriving the unit hydrographs. Because once unit hydrograph is derived, right, for a particular basin, you can derive unit hydrograph any time duration, and that is basically, it does not change with time. So at any time you can use it in future also. So that is why for any storm, whatever thing we want to get a unit hydrograph. Previously what we got for an isolated storm, for a specific period the rainfall was there. For that particular thing, how to derive an unit hydrograph, we started from there. Now where we have entered, multiple storms are there. In such a case, how to derive the unit hydrograph. For example, for a particular basin, you do not have an isolated storm. Then in such a case, what is the alternative? You have to go for take the data of a complex storm and then get the UH. Still we can get the UH, no worries at all. So that's why when a suitable simple isolated storms data is not available for us, then naturally we have to take the data from complex storm of longer duration and will have to be used in deriving the unit hydrograph. Otherwise, generally we don't touch upon the complex storms. Always we prefer to have the isolated storms, and from the isolated storms we derive the unit hydrographs. But here the problem is the isolated storm, the data is not available, then we have to go for the complex storm data, which is of longer duration. Then from that also we can derive the unit hydrograph. Unit hydrographs can be developed even for complex storm with varying rainfall intensities. This is done by breaking the complex storm. This is very, very important. This is done, how we are doing it? By breaking the complex storm into a series of smaller successive unit storms actually. So what I am doing here is that complex storm is broken into number of actually isolated smaller storms actually, right? With each with a different intensity. The runoff hydrograph resulting from such a complex storm is considered to be the superposition of the hydrographs from these individual storms. So this complex storm is broken into smaller storms actually. Each smaller storm is an isolated thing. If all these smaller storms are superimposed, then automatically your complex storm is obtained. So what I am doing is I am splitting the complex storm into number of storms actually. Each one is having different intensities but specific actually. That's what I am doing. Each of these individual storm hydrograph is calculated by multiplying the storm. That's what I will show you also, how I will do it also. So what is given is, this is given to you, and what is required is, this is being asked to determine. So that is what we are going to do it. So now how I will do it, the methodology I have explained here, but I will do it in a problem so that you can understand better. Let us move into the problem actually. So what is the question that is given to you? Complex storm data is given to you, and what is asked actually, you are asked to derive the unit hydrograph. What is the principle that you are using? This complex storm is broken into a series of smaller storms actually, which is occurred one after the other. It's occurred one after the other. Each one may have different intensities. So that I have taken, and from there I am trying to find out the unit hydrograph. How I will do it, and then whatever I have written here, I will show you in the problem. So what I am doing is, there are three storms here, you take it. One is the intensity is R1, the second one is intensity R2, third one is R3. So this total actually is the complex storm. All total put together is the complex storm. So now you have actually one storm is R1 maybe 2 centimeters, R2 maybe 4 centimeters, R3 maybe 3 centimeters. So like that you have, right? Each of the duration, for example, this duration is constant. Suppose this is 3 hours, this is also 3 hours, this is also 3 hours, right? This axis may be 2 centimeter, this axis may be 4 centimeter, this axis may be 3 centimeter. But each one is duration is 3 hours, 3 hours, 3 hours. That is the thing. So this complex storm is, this is the data that is given to you. Now what I have done, I have divided it into 3 storms actually. So that is the first thing. The complex storm is broken into 3 storms. One is first, second, third, right? Now what I have done is, due to this storm, what is the direct runoff hydrograph? Due to this storm, what is the direct runoff hydrograph? Due to this, what is the direct runoff hydrograph, right? For example, if I take U0, U1, U2, U3, U4, U5 are the ordinates of unit hydrograph, right? What is the direct runoff hydrograph for the first one? You tell me. If this is unit hydrograph, I am assuming, for example, and this is what I have to derive at the end. Suppose I take first storm only exists, then what is this ordinate actually? You tell me. This basically first one is generally 0. So from here, this R1 into U1, R2, R1 into U2, R1 into U3, because this is UH ordinate, this is direct runoff ordinate. Direct runoff ordinate is nothing but unit hydrograph ordinate into depth of direct runoff, right? That depth of direct runoff is given. That is what he says, rainfall excess. So he multiplied by this. So this is the first storm. The second storm occurs when first and second storms both occur at the same time? No. The second storm starts when? After the first storm. After the first term is how much time? I told already the first term is how much time? 3 hours. So the second term starts with after 3 hours. So that you take it, and after 3 hours you put it. And what is the direct run of hydrograph for the second one? This multiplied by the unit hydrograph. But this should be ordinate should be at what time? After 3 hours. And this should be again when? After 3 hours. And this multiplied by the unit hydrograph ordinates will give you direct run of ordinates. So now all the total has come. Finally, all this is equal to what? The complex term, whatever data is given, it is equal to that. Find out what is U1, U2, U3. That's all. So that I will show you the method also. So that's what I told. What is the method actually? For example, if I take it R1, R2, R3 centimeter. Let us assume, this is first what we will assume is, we don't know. We have to calculate this only. That UH you have to derive. Take it. Then consider first term. What are the direct run of hydrographs of the first term? R1 multiplied by this. And what is the second term? R2 multiplied. Third term? R3. So first term data as it is, I have put it. This is direct run off. And second term occurs how much time? After 3 hours. So that's why first I put it, same reproduced. Second one is R2 into. Third one is what? Again after the completion of the second term. This. Now sum it and equate it to the complex term hydrograph which is given. Equate it. Find out what is U1, what is U2. Find out. That is the solution. So what is the 1 minute let us discuss on this actually. What is our method? Complex term is given. So complex term means the complex term direct run of hydrograph is given to you. Now what you are doing it is, you are dividing it into number of storms. Each storm is having some separate intensity. So what next you have done? Assume the unit hydrograph ordinates. So unit hydrograph ordinates multiplied by the first storm direct run of depth is equal to the direct run of ordinates due to the first storm. The second storm, when it will begin? After the first storm ends actually. When the first storm ends? After 3 hours or 4 hours or whatever it is given in the problem. Then the second storm data. Then after the second storm ends, third storm data. Then sum all these things is equal to complex storm direct run of hydrograph. So then you get what is U1, U2, U3, etc. So this is what we call it as this method, how to derive a unit hydrograph for a complex storm. I will show you that. Straight away I am going to an important problem. The stream flows due to 3 successive storms of this centimeters of 6-hour duration. Each storm duration is how much? Each storm duration is equal to 6 hours. Please note it. Right? Then afterwards, what is given? The area of the basin is given. Good. Assume a constant base flow of 20 cumecs. So the second data that is given is base flow is equal to 20 cumecs. Derive 6-hour unit hydrograph for the basin. Average storm loss is this is very, very important, this average storm loss is equal to 0.15 centimeter per hour. So that means whatever these things are, only whatever that centimeter is only the rainfall. But what we want, rainfall is 2.9 centimeters for the first term. Loss is how much? 0.15 centimeters per hour. How many hours this first storm is there? 6 hours. So what is the loss in 6 hours? 0.15 into 6. So now effective rainfall is how much? 2.9 minus 0.15 into 6. How much it will come? 0.15 into 6 is 0.9. So 2.9 minus 0.9, 2 centimeter. So due to the first storm, What is the effective rainfall is to come to the second one, 4.9 minus 0.15 into thing, and third one 3.9 into 0.15 into 6. So if you take it, the effective rainfalls are 2 centimeters, 4 centimeters and 3 centimeters. These are the effective rainfalls. Effective rainfalls. This is for 6 hours. This is for 6 hours. This is for 6 hours. That is the thing. So this is the thing. Now the flows are being given to you here. Then right, how to go forward. See what I have done. Let the ordinates of 6-hour unit hydrograph, I am assuming like this. I am assuming at 0, 3, 6, 9, 12 up to 21. That is what is given. Because I am taking only limited. Why I have taken limited? Why not you are taking up to U11 also? Then the problem goes, you also will understand. Maximum this is enough in any problem that is given to you. The direct, that I will also show you why I have taken up to 7. I will show you. It's not just simple. Don't assume that I have taken only 7. Because here if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 are there. Anyhow, U0 if you are taking for 0, at least 11 should come. But I stopped at 7. You understand why I am taken 10 at 7 also. The direct runoff, first thing, this is what the flow is given. This fellow has given base flow. So naturally, total flow minus base flow will give you the direct runoff hydrographs. Am I right? Any difficulty in this? First one, complex storm hydrograph is given. Base flow I separated. I automatically got direct runoff hydrograph. If in a problem base flow is not given, you can assume it as 0. Automatically you get these answers. Right? That's the thing. Then, what is the effective rainfalls? First question is direct runoff hydrograph. Then second question is what? What is the effective rainfall? So this is the effective rainfall. Just now I explained to you. Right? Third step is also over. Now what should I do? What should I do? This is the storm for 6 hours. This is a storm for 6 hours. This is a storm for 6 hours. Right? For 1 centimeter of direct runoff, these are the ordinates. For 2 centimeters of effective rainfall, what are the ordinates? It will be 2U0, it will be 2U1, 2U2, 2U3 and so on. Am I right? And what is this ordinate second storm? It will be 4U0, 4U1, 4U2, 4U3 and so on. For the third storm, what are the things? 3U0, 3U1, 3U2, 3U3. So these are the direct runoff hydrograph for each storm. All the storms occurred at the same time. First storm is, if it is 0, 0 to 6, this is the first storm. 6 to 12, this is the second storm. And 12 to 18 is the third storm. So this is first storm, this is second storm, third storm. So the second storm starts when? After 6 hours. Third storm starts when? After 12 hours. Please, these are the crux actually in the unit hydrographs. All storms are not starting at one time. The complex hydrograph is divided into number of isolated storms, one after the other. So the first storm is 2 centimeters is for first 6 hours. Then 4 centimeters is for next 6 hours. And 3 centimeters is for next 3 hours. So have clarity. Problem is simple, but only clarity. So this is the unit hydrograph which I am assuming. Time interval, whatever is given, I have taken. I have taken up to here only. Understood? Why I have taken up to here, you can see it also. You yourself can judge in the mind, and in any problem you can yourself can take it very easily. Nothing, very simple. Then what is the direct runoff due to first storm? First storm is how much actually? 2 centimeters. So multiply these ordinates by 2 over. As it is, I have done starting from 0. Second storm will be after how many hours? 6 hours. So naturally it starts from 6. That's what I have. Because after the first storm ends, then only the second storm. The first storm is for 6 hours. Then this starts after 6 hours. And this is for 6 hours. But this will start after 6 hours. And this will start 6 plus 6 after 12 hours. So that's why I put here. Then rest is as it is. Only thing is I multiplied by the unit hydrograph ordinates with this effective rainfall. Third storm, when it starts, again after 6 hours from here. So this is. Or it starts at 12 hours. Fine. Anything is okay. Then multiplied by 3. So now you have 3 direct runoff hydrographs occurred one after the other, each producing a rainfall excess of 243 centimeters. Now what I have done, this total should be equal to the direct runoff. So what is the direct runoff? Storm flow minus the base flow. So now if I sum it up these three, this from here to here, if I sum it up, so now 0, so I put here. Then here it is 2u1 is equal to the direct, he has given it as storm hydrograph 50 minus base flow, so u1. Then this column you see it, then see like that what I have done. You can question me, why u7 only you have taken, sir? Why you have not taken here? Now I told you, the moment I look at the problem, I know the first storm is for 6 hours. The second storm is after 6 hours it starts up to it goes here. The third storm starts after 12 hours. It goes to the end. Where is the space? If suppose I take U8, U9, U10, U11, where they will go? Where they will go, you show me. What is the use for me? Absolutely no use. Why? Because you have already got U7 itself is 0. Then you take U8, U9, U10, U11, all will become 0, only time waste process. So that's why while observing the problem, see basically that things. So each is given 6 hours, 6 hours, 6 hours. So the first one is beginning, second one is after 6 hours. So that means 2 time intervals gone. Third one is after 6 hours, 2 more time intervals. So bottom 4 intervals I have removed, and then now I counted actually. 0 I don't count. The remaining I counted. That's as good as any problem. That's the way you need to think like that. Then it's very easy. Otherwise it's only summation. Put it and get the answer, nothing. And at the end what I have done is also, I have checked whether I am right or wrong. How can I check it? These are all the unit hydrograph ordinates. So I found some. We know the depth of direct runoff for unit hydrograph. What is the depth of direct runoff for a UH? How much? It should be 1 centimeter. I have checked it, 0.36. This is unit hydrograph ordinates into time interval divided by A, because he has given A. It should be equal to how much? 1 centimeter. I checked it, I got 1 centimeter. Then I told that answer is right. The method is working very, very well. Now again another problem, you try to solve it actually. So here what I have done, 3 storms, one is 8 centimeters, one is 3 centimeters, one is 16 centimeters. So first one is R1 is equal to 8 centimeters, R2 is equal to 3 centimeters, and R3 is equal to how much actually? 16 centimeters. So what I have done is, I have assumed the unit hydrograph ordinates, multiplied by this. So direct runoff first one, multiplied by this. I will get the second one, multiplied by this, I will get the third one. But while arranging, how should I arrange? Each one is how much actually? 3 hours. So I should arrange first one straight, second one is after 3 hours, third one is after 3 hours again. So now sum it up and equate it to the here the base flow he did not give. Whatever direct runoff hydrograph ordinate is there, equate it to it and get the solution. I have assumed same way actually. So now why I have taken up to 7? You know that first one is as it is, second one is 3 hours will go, third one is again 3 hours will go. So naturally first one gone up to this, second one gone up to this, third one gone up to this. So that's why I have taken up to U7 only. So that's why while observing the problem, I will observe how many unit hydrograph ordinates I have to take it. So that is the most important. Even if I take after this also, absolutely no use, you get 0 answers, time waste process only. This is only common sense. Suppose if somebody fights with me, I will take U8, U9, take it, no issues. What it will happen, if you take here U7, U8, U9 you will put it. Then afterwards here what you will put, 8 will come. Then afterwards here it will come, nothing. So naturally if you sum it up also, where is the ordinate to sum it up? You tell me, sum it up. Then naturally already U7 is 0. U8 also become 0. U9 also become 0. So there is no use actually. So now first storm I have taken. How much is the thing? Right? Second storm starts when? After 3 hours. Into multiplied by what? 4. Third storm starts after 3 hours again. Now horizontal thing is sum. I have to sum it and I found out what is this. This is the answer. So thank you very much. I have completed again one more topic called as how to derive unit hydrograph from a complex storm actually. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.